In this video, we're going to start to learn about some of the parts of a C program. So I'm just going to go ahead and open up a terminal and get over to the server. I have a nice alias. If you come to class, I can show you how to create your own alias to get onto the server, or you can just always type out that SSH command. So I need to log in here, and I get dropped right in my my directory. I can see where that is, home, and then my NetID. And my ls, list contents of directory, shows that I have that directory that we created. It's my Git repository for the class. But I just want to show an example that comes from the book, and it's already on the server in the public directory. So you can go to this directory as well. You just need to remember to include that slash there. So if I do cd public, where am I now? I'm just in public. And what's in here? Well, there's actually a bunch of C code in here. These lab 1, lab 2, program 1 directories, those are actually from a previous class, but the examples, so I guess you can look at them if you want, but they might not be the same assignments that we have. So maybe helpful, maybe not, but we are going to go take a look in examples, and let's see what's in here. There's a bunch of examples for some chapters that we're going to cover, and today, in this video, we're going to look at chapter 2. And in particular, we're going to look at this miles to kilometer.c file. We can look at it with Vim. And actually, so everything in this public directory is just going to be read-only for you. So the best thing to do is going to be to copy this using CP. So copy on Linux, we're going to first put in what we want to copy, and we want to copy this file. And we're going to want to copy it to our home directory. So we can use tilde to alias to our home directory. And then I'm just going to leave it the same name. And if I want to just use the same name, I can actually just say dot. That's saying copy that thing to that folder. And if I press enter, it's going to run that command. And now let's just go to home and see if it's there, and it is. So now I can actually make edits to this file. So let's use it to learn about parts of a C program. So the first thing that we see at the top of this file are what are called preprocessor directives. So these are the include statement and this define statement. And these are run sort of before, when we go to compile this into an executable file that we can actually run, these preprocessor directives are run before the compilation happens. And the two types here are our include statement, so #include, and that is saying that we would like to use the functions that are defined in the stdio.h file. So this is the standard input and output. And .h is just another way to indicate that it's a C file. So we've been calling our C files .c. .h is also a C file. And we'll use some other header files like math, I think, and maybe some others throughout the class. But the include preprocessor directive allows us to use predefined functions. We also have the define, #define preprocessor directive, and this allows us to define constants. So what's happening with this define statement is that anywhere that we write this in our program, it is actually going to go through and replace it with whatever we write next. So in this program, I can use Vim's search functionality, which I do by, so I'm in normal mode. Remember, we got normal mode, we got insert mode. I'm in normal mode, I press /, and then I start searching for whatever I write here. So if I want to do the entire thing, I type it out, I press enter, and now I've searched for these things, and I can press N to actually toggle between them. So if there were a bunch, I would just, and my file's super long, I'd be toggling all the way down through. So before our program gets compiled, this KMS per mile would get replaced with 1.60934. So this is really useful when you're writing programs where you have constants like this, just to find them at the top. Then if you need to change them later, you're not dealing with lots of places that you're going to need to change that number. It just makes your program cleaner. So we saw our preprocessor directives. I'll just get rid of that highlighting of what I searched for, using :NOH for no highlight, so stop highlighting it. We also have some comments here. So we can write comments using 2 /. Those are how comments were defined in C++, I think. We can also use the /* to start a comment, and then we always have to end it with the */ again. That's how comments were originally defined in C. So this is sort of a C-style comment, and our // comments are sort of C++ style comments. We also see our main function. So we always have to have a main function in our C programs. And we'll learn all about functions, so if you haven't programmed before, maybe this doesn't make a ton of sense, but that's okay. It's just important to know that this is the main function. We always have to have one. This first int here is saying that it's returning an integer, which goes back to the operating system. And as long as the operating system gets a 0, then it knows that the function, or the program, ran successfully. We always have to call our function main, our main function main, and it doesn't take in anything, so we can either put a void in here or we can just leave that blank. I think in general when you're programming, it's best to be explicit. So I just like to put the void in, but you can leave it blank if you like. Everything in between these curly braces is the body of the main function. So all of this here is the body of the main function. And inside our main function, we have 2 types of statements. We have declaration statements, like these ones, where we are just declaring variables. So what these are, this is just telling the computer, reserve memory for a variable miles and reserve memory for a variable KMS. And then everything after that is actually an executable statement that actually either assigns a different value to variables or gets input from the user, prints to the terminal. All those are executable statements, but definitely will be on the quiz on Friday or whenever that is this week, this difference between declaration statements that just reserve memory and executable statements that actually do something. So ask about those in class if you're confused. So in these declaration statements, you might see that we are telling the computer that this variable miles is a double, and that's a data type. So all of our variables we always will have to declare them with a data type. So double is something like our 1.60934 up there. We also, in this class, we will use, or for right now, we will use ints. So an int is just an integer. For example, we'll just call it a, and now I could say a is -5. I could reassign a to be 10. And the third data type that we're going to use is a char. So for character, and maybe I make a char c, and when I assign a variable to a char, I will use a single quote, and then I can just assign a single character here. They can be capital. Oops, I think I'm not even using a quote. I'm using, oh, there we go. They could be capital letters. They could be characters like %. They could be characters like lowercase letters. These are all chars, but single characters. So those are our two data types. But let's just see what happens when we compile and run this. So to compile our programs, for now, we will use GCC, so that's the compiler. We'll say -o to indicate what our output executable file is going to be, and we're just going to call it m2km, and then we use the -wall flag to say show us all the errors, and what's the file we want to compile? It's m2km. Then I press enter, and because there were no errors, I don't see anything. Now to run this, I'm just going to just call that executable file. And this asks me for some distance in miles. I press enter, and then we saw that print statement use that conversion factor. So one last thing I wanted to show, let's go back into that file. So we have these statements where we actually assign data to a variable. So for example, on this line, we're assigning whatever KMS per mile times miles is to KMS. So this is called an assignment statement. We call this =, the assignment operator. And so I just don't want you to be confused about this being an equal sign. It's not really doing anything with equality. It's just assigning the variable KMS to some value. And to really see what's happening, to try to understand it, I like to go over to, let's see if we can get back to this browser tool that is this C code visualizer. So what this lets us do is paste in some C program and actually see, give a visualization of what's happening at every step. I just think this is awesome. So let's get our program. So since we're over here in Vim, we can't, if I try to copy this, I'm gonna get those line numbers, right? So a really nice thing about Vim is you can toggle your those configuration settings that we have in our vimrc anytime if you just want to change something, you can always type, if you're in normal mode, you can type colon, and let's say I want to have no line numbers, I think. So let's try no number. Nope. Okay. I think set no number is it. So usually you can either ask me in class, ask me on Slack, ask the group on Slack in the Get Help channel, or you can just Google, remove line numbers from Vim if you ever need to do this. Because now what I can do is I can copy this. Maybe that's going to copy this set no number. Ooh. I can just copy this right over here. And this tool actually isn't going to like scanf at all, so I'm just going to, instead of having the user enter the distance in miles, let's just set miles ourselves in here. So I'm going to say miles is 10. And now, if I press visualize execution, it's going to basically generate this visualization where I can walk through and see what happens. Because I really want to use this to show what happens in these assignment statements. So first thing to note here is this red line is showing us what's the next line that's going to be executed. So these preprocessor directives, like I said, they're not C code, they're just things that get done. They get executed sort of by the compiler. They're already done. So the first thing that's going to get executed is our main function. So we jump in. Oops, I kind of did that twice. This little green is what just happened, and the next line. So as soon as we jump in here, our declaration statements, you can see, have reserved memory for our miles and our KMS variables. But there's nothing in there, really, yet. But they're doubles, so the amount of memory needed for a double has been reserved. Now, let's go and see what happens when our assignment statement gets executed. So I'm going to run that. And we can see that now what that did is it changed what was written in memory to a 10. And what's going to happen next is this KMS variable is going to get rewritten with whatever this evaluates to. So we run that. And then the next thing that's going to happen is we're going to print this. And this tool has a little print box here. And then next is our return statement. We're not going to see anything happen there. And now I can't do anything more, so it's done running. So I just wanted to show what our assignment operator does, right? That equals is the assignment operator. And that will be it for this video.